Hello everybody, this is a video tutorial of OpenDS on how to generate your own driving cars. In this tutorial we show how you can start from scratch by maybe downloading car models and make them available in OpenDS. So all we need is a fresh installation of OpenDS. I downloaded OpenDS 2.5 for this tutorial, and the graphics, the modeling editor Blender. As you can see here, I'm using an older version. Actually, it's version 2.49b, as this is the last known version which supports the Opera XML exporters that will be needed later on. First, let's start with the model I got from any source. I first have to import this model. There are several formats available, but I choose for 3D Studio. Okay, I will import this model, and as you can see, there are several models of cars contained in this one file. So first of all, I would need an overview of what is available here. So you can see from these labels that there are several types of cars. Yeah, it's quite some sorts of cars. You can also have a look at the camera view. So we have several passenger cars which have some textures, and we just pick one of them, extract it, separate the wheels, and export it to a format that is readable by our OpenDS simulator. So first of all, I delete the other cars that will not be part of this export. So let's choose for the Audi S6 here. So the remaining cars have been deleted. And this one is where we want to start from in the generation of a driving car for OpenDS. So first of all, you can see this car is not standing close to the global coordinate system, so we will have to shift it. I open the transform parameters window here. And as you can see, it's located outside the center, so I first set the pivot point to the center. Also the rotation is something I set to 0. Scale, I will scale the car to 1, and I will have to zoom out in order to see the car again. Okay, there it is. Now I'm going to rotate the scene to have the car again upright. In order to bring the car close to its pivot point, which is now located in the center of the coordinate system, I have to switch to the edit mode and use these arrows to transform the whole meshes to the origin. So first in X direction, also in the Y direction. So we can go closer. You see this tiny point here, which is actually our pivot point. I will bring the car center to that point. So I go really close there to bring it to an overlap. So now X and Y are overlapping, and I will rotate by 90 degrees. To also bring the Z-axis to an overlap here. So, and again, move it down. Okay, so going back. Yeah, as you can see, it's still in the center here. Okay, so now we have a look back in the object mode. Now we have deleted all the translation information, the rotation information, and we have scaled our car to 1:1:1, which is quite important for the use in OpenDS. So next we will have to align our car that the car is facing towards the y-axis. So for that purpose I just rotate my coordinate system, making the x-axis look to the left and the y-axis downwards. So, okay. Now I have to rotate my car, making it facing downwards from a top-down view. So first of all, I switch back to edit mode here. Then I transform, select the rotation on axis. I first pick the y-axis and I rotate by 90 degrees, making the car facing us. Yeah, this is quite tricky to get it exactly. Okay, now we rotated around the y-axis. We have to repeat this for the x-axis, making the car looking downwards, so it's also rotation by 90 degrees to the negative 90. Okay, so this is almost the final result of our rotation, scaling, and translation. We have now made the car look alongst the positive y-axis with the positive x-axis to the right and positive z-axis facing upwards. Okay, now we have the whole model still as one piece. We will have to separate the wheels in order to make them able to rotate in the simulation. For this purpose, we are using the separate tool, which can be achieved by pressing the P key on your keyboard. Then you will be asked what you want to separate. I will choose all loose parts, and if you have a look at the box on the right, there will be a separation of the master model. And now we have several parts in the outliner. We have to go through this list now, and we have to find all the parts that belong to the wheel. So I rotate the car to get a better view of that, and as I have found parts that belong to the front right wheel, actually it's in our case 4 parts of each wheel, so it will be this part and the next 3 parts, so it's 4 in total. I select them all by pressing the Shift key to multi-select them. Then you have to join those objects again by choosing the Object menu, Join Objects, or also Ctrl-J. Yes, I'm sure. And 4 meshes will be joined to one single mesh. So you better rename this in order to reuse it later on. So what you will have to do is to rename the mesh to wheel front right in this camel case, as otherwise the simulator will not be able to distinguish between what wheel belongs to what side, to the front, to the back. And also the object could be named uniquely in order to have a better overview in the outliner on the right. So let's call this front right. So it's ordered alphabetically, so you can see it somewhere else. Yeah, it's at the bottom now. This has to be repeated for all 4 wheels. So the right back wheel consists of those 4 parts. We again join them. And assign respective names to them. Now we have the right half of the car ready. We have to go to the other side. I just turn around. For the front left wheel, it's those 4 meshes. I also join them. This is the front wheel, left, and last but not least, we have the back wheel on the left. It has to be joined. And of course, all the remaining parts are the chassis of the car. So what we could do here is we select all, and and exclude those that don't belong here. So the wheels, so only parts of the chassis are now selected. We do it in the same way. We join those objects, join selected meshes, and what we do here, we also provide a name for that. So you have to be careful to spell it with a capital C at the beginning in order that it will be correctly recognized by the simulator. For the object, we call it chassis here, and we have now all the parts together in the outliner that are required for the simulator. What we do next, we select those pieces that we want to export. We go to the export menu. I already installed the OCRIM exporters, so it's one exporter for the scene and one exporter for the meshes. You would have to install both of them. Maybe you have to install Python as well if not done. I start with the scene export here, and let's select the path here. We go to OpenDS installation. I'll first have to go there and create a folder. I go to the assets folder, to the models, where we have the cars. We distinguish between static cars and driving cars, as static cars still have their wheels attached. Driving cars are chassis and wheels separated, as we are doing now. I create a new folder for our new car here. It's an Audi S6. I go back to Blender and select that folder, the assets folder, models, cars, driving cars. Here's our new folder, Audi S6. Choose this as export directory. You have to make sure that all the parts you want to export are selected here in green. If not, you can do this here. The file name should be car.scene, and if this all fits, then you can click export. Okay, so this was export of the scene. Now we have to do this again for the meshes. We select the OCRIM meshes exporter here. You also have to make sure that everything you want to export is contained in this drop-down menu. You have to specify the same path here. We go again to the OpenDS folder, the assets, where we have the models, the cars, driving cars, and the Audi. This is our export folder, and we have to make sure that the material file is called the same, exactly the same as the scene before. So we had car.scene. You have to make sure that the material file is called car.material. Yes, we have textures, so make sure that this box is checked. If everything looks like that, you can click export. Sometimes there will warnings appear, but this is okay unless there are no errors. Then we click OK. We can leave the exporter, and we can have a look at driving cars. So the Audi S6 folder we created is now filled up with the meshes as XML files. You see the chassis, you see the whole wheels. We have a scene file which references to the meshes, and we have a material file which applies the texture. So you can also have a look at the texture. of our car, which is applied to the meshes here. There's only one thing missing that has to be applied in order to make the Audi drivable. So we have to add a car properties file here. I go one up as I have already prepared this file here. So I move this to the Audi S6 folder, and now we have a look at it. So in this properties file you can specify several attributes about the car. So first of all, you can specify the positions relative to the car where the eGo camera or the outside camera will be placed. You can specify scaling factors, so you can specify what extent the car will have, what extent the wheel will have, as the wheel scale is here available, friction slip of the wheels, the suspension, the length, the stiffness. This whole block is the configuration of the headlights, and rather important is what you can see here. So in this block you can specify the relative positions of the wheels. So this is the position of the front axle relative to the center of the car, the back axle. So this means the back axle is 1.2 meters behind the center of the car. The left wheels are 79 centimeters shifted to the left, the right wheels 79 centimeters shifted to the right of the original position of the car center. And the height of the axle in that case is 20 centimeters. You can get these values directly from Blender. If you go there, for example, you add a sphere. Let's make the sphere a little bit smaller. And you can place this sphere to the original position of your wheel. You can have a look from the downside. And you know we have to move it here. Now the center of this sphere is equal to the center of your wheel, and you can read the values directly from the transform properties here. So you see the x value is minus 0.8 of the left wheel's position, as almost 0.8, and as well for the height and the position in front of the center. Therefore, it was important that we place the pivot point of the car in the origin of the coordinate system. This helps us now to read the relative positions of the cars from the transform properties here. So you can do this with all four wheels and apply those figures to this block here. Another important part is center of mass, where you can specify the relative location of the center of mass relative to the center of the model. So if the center of mass is too high, the car will not make the turns and will land on the roof of the car. Now we go back to the simulator and we want to test what we achieved. For this reason, we go to one of the existing driving tasks. Let's pick the terrain task. there we open the scene XML where already a car is applied, and we just change the path here and name it Audi S6. Now we reference to the scene file of our newly created car. And we start OpenDS. With that model. And what we get to see is the Audi S6 with the wheels at the proper positions. We can now have a look at the center of mass if we press the F6 key, and you can see this tiny spot in the center between all the wheels that is pointing downwards. This is currently our center of mass, where all the 800 kilograms mass of that car will be applied. You see the suspensions of the wheels. And in order to show you that we have some impact on those properties, I just go back to the properties file we have here. And for example, let's just scale the wheels to make them double in size. And let's just pick the center of mass to be higher than currently. So this will make the car fall over much more easily. We start again. And now you can see the size of the wheels is double as before, and there's no spot at the bottom, so you see the center of mass is now in the center of the car, which makes the car much less stable than before. So we can have a test drive now. And as a result, you see it's very, very unstable here. Okay, so this is already the end of the tutorial. Now I have showed you with one example how to add new cars. It can be done with other models in a similar way. Be careful to create the properties file in a correct way. You can a little bit experiment with the suspension properties here. You have to take care that the wheel scale, the chassis scale, that they fit to the real extent of your car. and here you can specify the positions of your four wheels. I hope you enjoyed this webinar, and we hope to see you soon. Goodbye.